All right, we're up to podcast number 28. We have this function x times e to the negative x. And if you take a look at the graph of that, by the way, it's saying x is bigger than or equal to 0. So that basically looks like this. The x function is going to try to make it go up, but then the e to the negative x is going to bring it back down. And it's never going to quite hit the x-axis, but very close. The first thing to do is verify that it is a probability distribution function, which means that if you integrate all of this, then that should equal 1, which represents 100% of all the whatever you're talking about. Could be cats, it could be basically with probability density functions, they could apply all kinds of things. The 1 is representing the 100% of whatever the things are. All right, so that's the first thing, is when you integrate, you should get a 1. This is saying bigger than 0, so that means integrate from 0 to infinity the x times e to the negative x function. And because this is a multiplication, I'm thinking that integration by parts would be a good idea. And also, if I let the u be x, the derivative of that's just a 1. So I'm hoping that integration by parts will work. And then also, by letting u equal x and dv being the e function, that we're only going to have to do integration by parts one time. So the derivative of x would just be 1 times dx, so that's just dx. And then on this side, do the antiderivative, and the antiderivative of the e function is the e function. Yes, you're right. We also need to consider the chain rule. The derivative of this would be -1, so divide by -1. Or multiply by -1. And then the way that I like to do integration by parts is then you just multiply on the diagonal. So that's going to be the x times the negative, and I'll just put the negative in front, the negative e to the negative x function. And then you look at the bottom row, multiply those, and that's what we need to integrate. So then it goes minus the integral of negative e to the negative x, and then times the dx. And then, so we would still need to go from 0 to infinity, but I'm just going to finish this work, and then we'll do the 0 to infinity. So negative x e to the negative x, and then these two negatives are going to cancel. And then the antiderivative of the e to the negative x is still going to be that negative e to the negative x. Okay, then we evaluate from 0 to infinity. And working with negative exponents, well, it's easier if you don't, at least for me. So I'm going to rewrite this as e to the x in the denominator, and this one e to the x in the denominator, and then evaluate from 0 to infinity. So first of all, if you substitute infinity, this would be infinity over infinity, because e to the infinity is infinity. This would be infinity. And whenever you have something like that, then really you're supposed to say, what's the limit as x goes to infinity of a negative x over e to the x? And because this is going to infinity and this is going to infinity, that's a great time to use L'Hopital's rule. So that will be the limit as x goes to infinity. Take the derivative on the top, which is just a -1. Take the derivative of e to the x, which is e to the x. And then we will have a -1 divided by, this is going to infinity. A -1 divided by infinity is 0. So the first thing that we would get is a 0. Then use the infinity right here, and that's basically what we just did over there to see that that's 0. So then this would be a 0 as well. And then minus, when you substitute the 0, this is going to be negative 0 over e to the 0, and then minus 1 over e to the 0. And then keep in mind, we're supposed to get the answer 1. Let's see if we do. So that's 0, 0, 0, and then negative, negative, so that's positive. And e to the 1 is 0, so it's going to be a positive 1. So good, we verified it. Now the good news is, for the other part, it said find the probability that x is less than 2. But the good news is we already did the antiderivative, so that shouldn't take very long. So the probability that x is less than 2 means integrate. Well, this thing starts at 0, and then we're going to up to 2. So if you integrate that function, then we already did the work to find the antiderivative. We just need to change that to a 2. So that's going to be the negative x e to the negative x. So I'm just working from here, minus e to the negative x, evaluated from 0 to 2. And then how much is that? So because I'm going to have e to a number, like a negative 2, I'm going to end up using the calculator. So for this, I'm just going to leave the negative exponent. So that's going to be, substitute the 2, so there's negative 2, e to the negative 2, and then minus e to the, substitute the 2 on that one. And then when you substitute 0, this is going to be 0 times something, so that's 0. And then if you remember, this one gave us a 1. So it's going to be minus, and then this one's going to give us a 0. And then minus, that is going to be a 1. And then how much does all of this equal? Well, this negative and negative would become a positive, so I can just put positive 1 right there. And then let's see what the calculator says. So the calculator says we've got negative 2 and then e to negative 2 minus an e to a negative 2, and then there's the plus 1. So that means that it would be a 0.594 as a probability, and then probabilities can be changed to percent, multiplied by 100. So in other words, the probability that x would be less than 2 is going to be 59.4%.